Yep.
Okay. Okay, perfect.
Cool.
Looks like it's recording now, right?
Yep.
All right, great. Hello, everyone. My name is Minko Gechev. I'm currently leading the Angular developer relations team at Google. And today I will be sharing with you what is the current state of Angular. So this presentation is particularly exciting for me because this is actually my... Oops, I muted myself for a second because this is one of my 100th presentation. So that's my
nice.
100th anniversary today.
Nice.
In today's presentation in general, we're going to keep it a little bit brief so that we can focus on a discussion at the end. We'll be looking at some of the theoretical foundations on some of the decisions that we have been making on Angular, and I'll give a couple of examples. All right. So Angular currently is being used in over 2,000 projects inside of Google, and of course, hundreds of thousands of projects externally. The fact that we have that many projects inside of Google allows us to, it has its trade-offs, of course, right? It first of all allows us to have really high test coverage. So this way, we're pretty much aware of any breaking change that happens in Angular at any point. If we change something and this completely invalidates the time semantics, for example, of different methods being called internally inside of the framework, we would know that pretty much the moment when we make the change. So this is great and allows us to be stable across versions. But at the same time, it makes us to be a little bit more conservative in making large-scale changes. You might have noticed how we spent about 2 years working on Ivy, and that was mostly to guarantee that we have such backwards compatibility given the large API surface that we currently have. So with version 10, we have focused on enabling some more strict behavior. Instead of making general changes to the public API, we're focused on enabling static validation and static optimizations that are happening in the build process. In fact, we are experimenting with new mode, which is not enabled by default, and we just love to collect some feedback. So Angular R10 version 10 RC is out, and in fact, you can even try the stable version 10, which is out for the past, I'll say about 2 weeks. We released version 10.0.1 last week, and this fixes some performance regressions that were happening in the Angular CLI due to some third-party Webpack plugins. Now, let us look a little bit and spend some time exploring the theoretical foundation behind the changes that we have been doing in the Angular CLI right now. So in general, I'm pretty excited about programming language design, about different trade-offs that developer needs to make there in order to make their programming language or framework both ergonomic and statically optimizable. So I would want us to discuss briefly predictability versus flexibility. Obviously, we would want a system to be both predictable and flexible, right? In real life, we can think of predictability as having a really tight, really well-defined schedule. For example, if someone looks at your calendar, like having 10 meetings a day, for instance, and going to work following the exact same route and eating the same lunch, preparing meal in the morning, like just having really well-defined schedule, which allows you to optimize for doing more things potentially. But at the same time, such very predictable and well-defined schedule in real life makes you a little bit less flexible. For example, if you would want to introduce a new activity in your day, it's going to be really hard because your day is really very predictable and optimized at a certain point. So introducing an adventurous activity, like, I don't know, like going to the doctor, like the most adventurous activity that I came up with, is going to be a little bit tough. So predictability versus flexibility is pretty interesting trade-off in real life, but obviously in computer programming as well. Often in programming languages and frameworks, we refer to the predictable behavior as static because this is available without running the application. This is available while compiling the application. So there is no runtime behavior. That's why it's called static. And dynamic. This comes from dynamic analysis, which involves running the program. For example, you can dynamically analyze a program by executing it and observing its execution. just observing its behavior and some metadata that has been collected over time. Static and dynamic often are competing concerns. And it's very interesting when we put different programming languages, because programming languages, we can very easily observe these static and dynamic characteristics in them. Idris, for instance, is a very static programming language. There are not too many production systems written in it, but it has really expressive and really powerful type system that enforces a lot of different static constraints which provide some runtime guarantees. Haskell is another example. If we compile our Haskell program, we are almost certain that there are not going to be any runtime errors. Especially when dealing with side effects, Haskell is really strict. It requires to use some special constructs called monads that are dealing really efficiently with such side effects. Rust is another example, which, see, it's going slightly more to the dynamic part of the spectrum. Rust, for example, it guarantees efficient memory management at compile time. So that's really powerful. On the other side of the spectrum, we have Ruby, which is super dynamic. We can do anything that we would want there. And we don't have any compile time guarantees because we don't have compile time process. We just start executing our program and we can potentially hit a runtime error. JavaScript is another example for a very dynamic system as well. We can run our JavaScript program inside of the browser, and well, we don't have any compile time guarantees. We're just interpreting the program. We're just letting the browser interpret our JavaScript program. Typescript is great, like it's somewhere in the middle. We have some static enforcement. For example, we have type system that guarantees that we cannot perform operations across incompatible types, but at the same time, it is not too static. It doesn't set us too many restrictions to make us unproductive. It is the right amount of static for most developers. It's very interesting to observe also that from a very restrictive system, we can just drop some of these constraints. We can just, for example, start using any in our TypeScript program, and we can go to a more dynamic system. But from a very dynamic system, it's hard to go to a static system. Because, well, for instance, let's say that we want to turn all the JavaScript programs out there in the world to be statically, to enable static type checking for all of them, to make them valid TypeScript programs with the strict flag of TypeScript enabled. It's going to be really hard. We have a very dynamic system already, which is super permissive. So making it more restrictive is going to be really tough. So it's easy going from static to dynamic, but it's hard going from dynamic to static. We can put some kind of more practical labels to both static and dynamic. For instance, static systems, they can enable a lot of compile time optimizations because our compiler understands the program really well. And we, in fact, have a compiler. This allows IDEs and text editors to support good type checking and auto-completion suggestions. We also have the ability to even perform some kind of source code visualization, because without running our program, we can statically analyze it and understand what is the relationship across the individual abstractions that we have. But on the other side, static systems often, they require some compile time. And we've been trying to make Angular compile fast. Like there is a lot of ongoing research in this direction, even in academia with different build systems. But well, like build time is never fast enough, right? For example, when I'm building my project, I'm never satisfied with the build speed. I always want it to be faster. So having zero build time is ideal. But at the same time, with dynamic systems, having zero build time is one of the benefits. At the same time, we don't have any of the guarantees that we have in static systems. One quote from myself, which is nothing novel, actually, this is something that many people have discovered much before myself, is that build errors are pretty good thing. In general, having a build error is the second best thing that can happen to anyone after having bug-free program. But Well, Dijkstra had a very interesting quote that it was about how many issues are there in one program, which is 100 lines of source, 100 lines of code. And there were like surprising amount of bugs in such a small program. We always developers know that with dealing with complicated systems, it's really hard to write bug-free software, right? At least I don't know a person who is capable of doing that. And I'm definitely not capable of doing that myself. So having compile time guarantees and compile time checks, getting build errors is a good thing because they're catching potential runtime errors. There was a paper by researchers from Microsoft and the academia that showed that Typescript helps you reduce 15%, helps you reduce the bugs in your programs with 15%, which is reasonable. And this paper was written for Typescript 2.0. So right now we are almost at Typescript 4. And it has much more expressive and much more strict type system, which can catch many more issues. All right, now let us put Angular into the picture. If you have used AngularJS in the past, you probably know that it was very dynamic. There was zero build time. You just take a bunch of scripts and you run your Angular application in the browser. Since we know that it's really hard going from dynamic to static, we started with Angular version 2 originally being super static. And we understood that, well, the build time wasn't satisfying, and also we weren't really able to get advantage of all the static optimizations this way. So we went a little bit more on the dynamic part of the spectrum, enabling more dynamic behavior. Later on, with version 9, with Ivy, we became a little bit more dynamic, so we can now easier load components. Lazy load components, for instance. And we believe that we're somewhere in the right part, in taking the right balance between static and dynamic right now. But still, we're trying to enable different static behaviors. So what is in version 10? In version 10, we're in general planning just two things. First, like obviously focusing on stability and providing an opt-in strict flag. Here, I'm going to discuss what this opt-in strict flag is, and we're going to look at a little bit in the Webpack's internals and figure out how the actual bundling works for different module formats. The increase of visibility is something that a lot of folks are actually interested in. In general, we're thinking of how we can revive our open design process so that we can share all the different design documents that are associated with different features that we're working on Angular so that anyone can participate in the design decisions. We're also looking into how we can be more open on the things that we'll be working on next. So we will be sharing something in between these lines in near future. Now let us look into the opt-in strict flag and see what it actually does. The strict mode is first going to enable even stricter type checking. It is going to enable strict types for Angular, and it is going to make ES5 support. It is going to disable it by default in the Angular CLI. So again, strict mode is not something that you would use by default in Angular. In order to create a new strict project, you'd have to use the strict flag. This is already documented on Angular.io. It's pretty much ng-new, the name of your application, ---- strict. And this is going to enable all of these restrictions in your application. So ES5 is kind of already legacy JavaScript, which requires a lot of polyfills and also doesn't take advantage of the latest expressive syntax in ES 2020 or ES 2015. And it just doesn't, it's just not necessary for us to ship it for our users, especially when they're mostly using newer browsers. You'll be able to opt in into ES5 with differential loading, something that we introduced in version 8, very easily if you're aiming to support older browsers, but we will be disabling it by default to encourage best practices and to speed up builds. Also, we will be disabling, we would ask you to opt in to use CommonJS modules. We will be discussing this in detail. And also we will be assuming that your source code doesn't produce any side effects so that Webpack can reshake it more efficiently. All right, so pretty much in the strict modes, the fact that we are enforcing stricter TypeScript, type checking, means that you'll be getting more of these. And these are not great because you're getting a lot of errors, right? A lot of folks who are starting with TypeScript for the first time are really frustrated by these build errors. But at the same time, as a reminder, these build errors are going to help you catch a lot of bugs before shipping your source code to production. So the pain, in my personal opinion, and according to this research, is worth it. Now let us dig deep into the opt-in CommonJS support and see why we decided to take this decision. So sometime back, about a month and a half ago, oh, actually, exactly 2 months ago, I wrote the article, How CommonJS is Making Your Bundles Larger. In this article, I'm looking at examples on how we're bundling different applications. So this is the first application. Here we have pretty much a couple of functions. We have add, subtract, multiply, and divide. And also we have a max function that is using max by from Lodash. And we're exporting them. We're just using CommonJS module format here. In CommonJS, you would export by using module.exports and the name of the function right after, just setting it as a property. And in index.js, we're importing only at, and just invoking it with some sample arguments. So for this, Webpack is going to produce an output which is several tens of kilobytes large. I believe it was around 50 kilobytes, which is really large given that we're just importing at and adding 1 and 2, right? We are not using max by, we're not using max at all. We're not even referencing it in our index.js. We're not referencing divide, multiply, any of these. And still our bundle is going to be over 40 kilobytes large. This is because in order to deal with CommonJS modules, Webpack needs to introduce some runtime so that it can import individual symbols from the utility module that we declared here at runtime. Notice here we have Webpack imported module, we have Webpack require. Pretty much Webpack is trying to emulate CommonJS at runtime. We're going to look at why Webpack does this exactly in a minute. Now, if we look at another example, this is pretty much the same example, but this time instead of using CommonJS, we're using ECMAScript 2015 modules. Here, we export add, subtract, multiply, and divide, and we import add from utils, and we're invoking it with 1 plus 2. So by taking this and passing it to first Webpack and right after that to the minifier cursor, we're going to get the following output. This is much smaller, right? And even if we add 1 extra pass to Cursor, Cursor will be able to statically evaluate that 1 plus 2 equals 3. So it will replace directly this addition with the result. So see, what is the difference? We have here CommonJS module and here the ES 2015 module. It doesn't look like such huge of a difference, but at the end, it is going to have a large impact on the output that Webpack would produce. So for the second example, when using ES 2015 modules, Webpack is going to take the utils module and it is going to place it in the same file as the index module. Notice here we have add, we have subtract. We're also going to have max and multiply. I have just dropped them for simplicity. Once Webpack merges these into the same module, it is going to invoke Cursor. Cursor is the JavaScript optimizer that we're using. Cursor is going to analyze which of these functions that we imported from the utils module we are actually using in index.js, and it is going to get rid of the rest. It is just going to perform dead code elimination. This is a very common code optimization technique that is only possible when our source code is statically analyzable. So this is the so-called tree shaking, in fact. That's how it works. Webpack first takes the individual modules, concatenates them into a single namespace, and right after that, Cursor gets rid of the dead code. Now, this is not possible in CommonJS because of dynamic behavior like the one here. Imagine we export a function which name we're taking from local storage by getting an item associated with a random number that we generate. So this is just runtime information from like everywhere, the way you look at compile time. There is no way for Webpack to know what is the value of local storage get item with a random number passed to it. So there is no way for Webpack to know the export name in this case. And there is no way for it to optimize the source code ahead of time. See how CommonJS is super expressive. It allows us a very dynamic behavior. We can declare, we don't have to have static identifiers as names of our exports. We can have anything gotten from anywhere, something like very dynamic behavior. And we have this freedom. So we have very dynamic system, which provides us a lot of freedom. But at the same time, it is not predictable. Very flexible, but not predictable. Now, I would want us to look at just 2 more examples regarding the static optimizations that we can do in the Angular CLI and to discuss their trade-offs as well. We also have zero overhead internationalization. So a very frequent feature request for Angular is in fact runtime internationalization. And runtime internationalization is, so just to make sure that we're on the same page what runtime internationalization means. There is a module called ngx translate, I believe, which allows you to directly swap your language just by clicking a button. Pretty much for each different string for your language, it creates a data binding. And for each data binding, you can just swap the translation pretty easily by clicking a button, which triggers Angular's change detection over the entire application. And this works fine, especially if this is a requirement that you strictly need. Well, you should definitely use ngx translate. If this is a requirement that you don't necessarily need, for example, if your users are not constantly changing the language that they're using, if they stick to a single language instead of changing them dynamically very often, you can stick to compile time internationalization that we implement by default in Angular. So with the way that it works is first, we take the source code of the application and we compile it to JavaScript. Also, we find where we have internationalization markers. And we insert some markers with identifiers of the individual strings that you'd want to be placed there. Right after that, we go to this localization stage where we build n different versions of your application for each one of the languages that you would want to support. And we replace these markers with the actual strings for the specific language. So this way, for let's say for 5 languages, you have 5 different versions of your application where the strings are now inline. The advantages of this approach are first, you don't really need data binding. You just have static strings this way. So this is not going to add extra overheads to your change detection, to the change detection of your components. Since you have static strings instead of data binding for each one of these translations. And second of all, these data binding instructions, they add up to your bundle. So having a data binding instruction is more expensive than just having an inline string. This way, you're going to have smaller bundles and also faster execution. Also, on top of that, we're able to actually tree shake your translation files. So since we're doing this replacement once ahead of time, we know exactly which translations you're using in your final bundle, and we'll be taking only them instead of shipping the entire like JSON or XML file with translations that you're using. All right, so that was most of it. I would be happy to continue the discussion. Here, I hope that you're able to see the trade-off of static versus dynamic, and I hope that I was able to explain properly how by having a static system, we can make some assumptions ahead of time so that we can optimize an application further. Yeah, I would love to actually hear your thoughts about the presentation, about the 100th presentation that I just did. I have a survey here on mgv.io/talk. And yeah, I would love to continue the conversation right now with the discussion.
Cool. Thank you very much, Minko. That was quite interesting. If you have any questions, we can drop it in the chat, and then I will unmute you, and you can just discuss with Minko directly. And I will ask the first question. What's coming new kind of in, Angular 11, some major, not major, but some
Yeah.
changes that we might see?
Yeah, so we will be sharing publicly a roadmap soon. We want this to be like clear for everyone. A couple of things that we're currently looking at is first to keep up to date with the Angular ecosystem. So we'll be looking at migrating and allowing Angular like soon. Yeah, that's a good question, when. It should be coming up really soon, really soon. It's a matter of let's say a week. Let's say 2 weeks or so.
Oh,
We
nice.
should. I can send you the URL. It should be on Angular.io. That's what we decided yesterday. So it's like a brand new decision. Don't share it with anyone. We will be keeping up to date with the ecosystem. So we will be updating TypeScript to version 4. This is kind of keeping the lights on right now. Also, we're working with Webpack very closely on making sure that Webpack version 5 works well with Angular. So this is going to bring some improvements in terms of build time. We have persistent disk caching with Webpack 5. So this is going to make your Angular applications build faster, especially, yeah, both actually code and mostly for code builds, since you'll be able to, Webpack will be able to reuse some of the artifacts from the disk every time when it has to rebuild your application. Another thing that we're looking at is dropping the previous version of the Angular compiler and runtime called the View engine. We will be exploring how we can make Angular libraries to be distributed without having us to build them with NGCC. As you know, currently the way that we encourage folks to distribute Angular libraries are by building them with the previous version of the Angular compiler. And right after that, you probably have seen something which takes a couple of seconds every time when you reinstall your Angular modules. We have compiling and the name of the module. So this is inconvenient, and we would want to get rid of it. So we'll be exploring different ways to just generate kind of intermediate source code for your libraries and distribute them on NPM. This is a pretty interesting project. It's going to have mostly impact on library authors. We are exploring some other things which are like in a very early stage. So I would prefer to share them as part of, I'll prefer to leave them for the roadmap. But there are some exciting things about development tooling and exploration on how to simplify Angular further.
Nice. Right, so got a question. Why did NG10 disable ES5 bundles by default? What was the thought around it?
Yeah, so we did it on 2 stages. In version 8, first we enabled differential loading. So we were shipping ECMAScript 2015 and ECMAScript 5. We were producing 2 different builds. And the users with newer browsers, they were able to take advantage of ES 2015, and older browsers were using ES5. And this was adding up to the build time a little bit. So we were down leveling ES 2015 bundles to ES5. So with currently more and more users just taking advantage of modern browsers, we thought that we really don't need to slow down the build process further, because most people are going to be using the ES 2015 bundles anyway. And also, there are some bugs in the implementation of so different browsers are handling differential loading slightly differently. If you look at Internet Explorer, for example, it is the way that we implement differential loading is with 2 different script tags, one with type module and one with attribute no module. The type module script tag is for the ES 2015 bundles, and the no module tag is for the ES5 bundles. If you look at the behavior of Internet Explorer, it is going to download both of these bundles. So well, you'll be downloading your application twice this way. I mean, that's fine probably because there are not too many people with Internet Explorer right now, but the differential loading implementation that is currently supported by the browsers is also not ideal. There were, yeah, that's the long answer. I can continue talking about this, but.
Cool. Will Google ever have anything for backend with TypeScript as well?
Yeah, that's unlikely at this point.
Right. Okay. I mean, the Nest.js. Do you refer to something like Nest.js? Ishan, if I say your name right.
Yeah, it's probably community-driven solutions would be the right fit for this.
Yeah, cool.
Google would be, yeah.
Go on.
So yeah, what will Webpack 5 module federation mean for Angular? Yeah, that's a great question. So with the module federation, we see a lot of potential for people developing and deploying large applications independently. We talked to a lot of different teams, and especially building really large Angular applications in big banks or airlines, who really wants to be able to have a team with, let's say, 100 or 200 Angular developers, which is decomposed into smaller sub-teams that are working on different parts of the application, and they want to be able to independently deploy their own parts of the application without coordinating with the rest of the larger organization. Module federation is probably going to enable such behavior for Angular without, or at least it is going to be a path forward, such feature in the Angular CLI.
Cool. Any other questions? Anything coming up for the forums?
So the forums, and cannot we do today already with Angular lazy? Yeah, you definitely can do that. It's a little bit hackier, but you can definitely do that with lazy loaded components and lazy routes. You'd have to probably do some have some extra infrastructure on top of the Angular CLI to be able to make sure that, for example, if the individual modules of the application are in separate lazy loaded routes, you should make sure that the cache invalidation works properly, that the bundle names don't change dramatically. These are not trivial problems usually to solve, especially around cache invalidation. The forms, they're on the roadmap. They're high on the roadmap. We are still figuring out good strategy for them, but there is a good community module actually, which came out, I believe, yesterday, I believe so. I can share it probably later today.
Was the Nathaniel, the one from Nathaniel?
Yeah.
I'm not. Yeah. Okay, cool. Got one from Ed. NG9 introduced NGCC, which increased CI build time dramatically. Is there something in NG10 to improve it?
Yeah, one of the things on the roadmap, as I mentioned, is how we can get rid of the ng modules, not ng modules, excuse me. That's another thing that we're looking at actually. Not get rid of them, but make them optional. What we are looking into NGCC is getting rid of view engine. So the reason for NGCC to exist is that we currently have two different ways to compile Angular applications, and we want to support both. So NGCC is the compatibility layer. Since we are looking into how we can get rid of the older model and look into how libraries can adopt the new model, we will be reducing the need for NGCC, and eventually we're going to completely drop it. This is probably not going to happen out of in the next few months, because we would want to keep older libraries still work with Ivy, but it is going to happen over time. There are already design documents in this direction.
Cool. Shareable Angular elements with other frameworks.
Yeah, you can already do that. So there is one thing that is just, Well, there are different approaches too. So we don't have out-of-the-box support in the Angular CLI. You can use NGX build plus to extend your build and produce Angular elements, which are like few kilobytes. But you'd have to ship them together with the Angular UMD bundle. So you'd have to use the entire framework. The problem there is that you wouldn't be able to tree shake the framework, the piece of the framework that you're not using. For some applications, that's fine. For others, it is not. Another approach would be to modify the build in a way that if you know which Angular elements you're exactly going to use on a certain page, you can bundle them together with the rest of Angular, and you'll be able to take advantage of like some tree shakeability. But Angular elements are already usable in other frameworks since they're web components. And as soon as the other framework supports web components, you'll be able to use Angular elements.
Cool. Yeah, I've done a talk previously on with Angular elements. I think when it was kind of firstly released, and yeah, you have kind of shipped the whole thing with it. But yeah, it's cool. I mean, that's ideal. In in the end, you build one component, you use it in any JavaScript, any website. Technically, you don't even need maybe JavaScript necessarily. Like a framework. That's gonna be cool soon. Right. Angular doc site is not indexed on Google, even though there's good answer for an issue on docs. Is not very accessible. Is there any plan to improve the doc site?
Yeah, I'm not aware which content is not indexed by Google. Google should be running JavaScript and indexing Angular IO. So if you have found a page which wasn't indexed, I'll be happy to, if you can share it with me so that we can look at it.
Nice. Any other question, guys? Is everybody on Angular 10 at their workplaces?
Yeah, it would be cool if you can share on which version of Angular you're right now. Yeah, I'll talk about.
Right.
I'll talk about Bazel also a bit.
Angular 9 with Ionic. Oh, still on 5.6.
5.6. Oh, 60. Yeah, actually, Freddy, it will be also great, Freddy, if you can share what kind of mod repo are you using. Are you building it with NX also? Okay, great. And also, why are you struggling to update it? Because it's usually the mod repo should be helping in the process since you have a single version of Angular.
I'm trying.
Oh, I see.
Right.
Okay.
Right.
For the folks who are on version 9, it should be pretty straightforward to migrate to version 10. It's like we just have this opt-in. You will notice few changes. We have an extra TypeScript configuration file so that we can make sure that like the solution, the base, TS base, to make sure that IDs are properly recognizing the different compilation context. For example, testing your application, end-to-end testing, and this should be the only difference that you're going to notice. Does Narwhal version 9 supports to? Yeah, I'm not sure on the Narwhal side. Although we're closely in touch with them, I'm not working directly with their team. There was a question about Bazel, and I'll continue with
yeah.
So Bazel was not deprecated itself. We deprecated the Bazel support in the Angular CLI. In general, if you're going to use Bazel, we recommend you to use it without the Angular CLI since it's not going to be able to, like the Angular CLI wouldn't, the strength of Bazel is exactly the static thing that we discussed today. So you statically explain how the individual Bazel build targets depend on each other. And Webpack is really dynamic. That is why it's really hard for it to make such sophisticated optimizations. they're working on this direction, but that's why Webpack version 5 is taking so much time to get out, because it's a very dynamic system going to a more static one. With Bazel, the strength is to have the individual build files and understand the relationship among them, so that Bazel can figure out how to run the build in parallel and take advantage of all the CPUs that you have on your machine. With Bazel, integrating it with the Angular CLI, we try to hide the boilerplate around definition of build files, and we kind of hide the main advantage of Bazel. And this was just not working the right way that we were hoping to. We tried to make it really with good development experience, but at the same time, we were neglecting some of the advantages that Bazel provides. So we just deprecated the integration with the Angular CLI, and now you can use it just like we do in Google. You just define build files and go from there.
Cool. Yeah,
boilerplate.
cool. Yeah.
Okay. Boilerplate in testing. If you can share examples with code snippets, we can look at it, but it's probably a good idea. So if you have an idea how to fix the boilerplate, this might be a good fit for a community library as well. Just something that it could be our official recommendation as well if it works out well. Would you advise to migrate from 7 to 10? I would recommend to migrate version by version in general. Yeah. You can check our update.angular.io guide. It advises you to do the same thing. Afraid to migrate? Miss a lot of return types for methods. Okay, you'll be getting a lot of type errors, I guess. Yeah.
How to modify component template during build time or custom builds? AOT doesn't allow to do that. Please,
Yeah.
can you explain build process of Angular?
Probably we wouldn't be enabling such behavior anytime soon, because this way you can plug anything as part of the compilation pipeline. And we're concerned that a lot of applications build performance can regress even further if, and there are a lot of unpredictable things can happen. We will make the builds more dynamic and less statically analyzable. So probably this is not something that we'll be looking at anytime soon. There are some folks from community who are excited on like plugging into the compilation pipeline, but so far we're a little bit reserved in this direction.
Ed and Bruno talked to each other before, probably. Is there plans to move to Jest?
We think that Protractor is something that is currently in a worse state, so we will be looking to Protractor next. If you prefer to use Jest, you can. There are some community extensions that with ng-add, you should be able to add Jest to your project. And definitely, if you have good experience with them, I'll be happy to hear what experience you have with them. Actually, you can feel free to reach out directly, either on Twitter or here, to share what is your experience with Jest in Angular CLI. Cypress, same thing. If you switch to NX, you will be able to take advantage of Cypress and Jest. What kind of data? So do you have any advice about Angular version 10 data visualization? What kind of data visualization is that? Oh, I see. Yeah, D3 is great. It's a great choice. There are a lot of talks by Aishigyo Yanet actually about Angular and D3. You can check them out if you haven't.
Yeah, D3 is quite nice and powerful.
Let me share her. Yeah, in general, Angular, if you type Angular D3, you should be able to see a lot of good examples and resources. Ayşegül's talks might be a little bit outdated now. I know that D3 had some breaking API changes as well. And so the talks from Ayşegül, although they're still great research, they are from a couple of years ago.
Cool. Any more questions? No.
Okay. Yeah.
Okay. Yeah. So if you, like Minko said, if you have any other questions, just fire them on Twitter, I suppose. And yeah.
Yeah.
Thank you guys all for joining. Yeah. Thanks, Minko. And yeah, we're gonna have somebody probably from the Angular team at some point, probably in the next 3 months, somewhere there.